welcome to this next video, guys. Today we're going to be talking about something called congruent figures, which is going to be very new to you this grade 8 level, but using some familiar ideas, but probably in ways that you haven't thought of before. Okay, so students will identify conditions for the congruence of triangles and deduce the properties of quadrilaterals. And by the end of this, you'll want to be able to determine whether two figures are congruent. Okay, and that's a particular term. We'll be going into it in a moment. All right, transformations, more than meets the eye. When we're talking about transformations, there are three main ones that we're going to be concerning ourselves with, and they are a type of transformation which is called an isometry. Okay, which means iso, so you might remember from isosceles triangles means same sides, but for isometry means the same measurement. Okay, so it means that if we had a Cartesian plane, so here's our xy, okay, and isometry would mean if we had drawn a triangle here. There are three types. There is the first one, which is translation, which means we just got the triangle and we moved it maybe over here. Okay, that would be a translation. We could also do a reflection. So that would be getting this triangle and we reflected it across the x-axis down here. Okay, so it's been reflected over this way. Or you can do a rotation, which means if we grabbed our triangle and rotated it around here, you might have something looking like that. Okay, so that's actually not correct. Let's just fix that up real quick. There. Okay, so if that's our three that we've got to be worrying about, which is our translation, reflection, rotation. Okay, and the important thing is that the measurement, so the size, so to speak, and shape stay the same. Okay, and it's really important. So that's the main thing we need to worry about in these ideas of congruence. This level in grade 8 is that they're the only types of transformations that you're going to be worrying about. Okay, so key ideas. When we're talking about something called a figure, so a figure are shapes, diagrams, or illustrations. Okay, so basically anything that looks like a shape in a picture, that's usually called a figure. Okay, and congruent figures, as we said before, have exactly the same size and shape. All right, so when the points are moved from one place in space to another place in space, the distances between those points may stay exactly the same. Okay, it's really important. That's our ideas of congruence. Okay, for example, this triangle here, it has just been moved, it's been translated, and then looks like it's undergone a bit of reflection. So how would we make that? Looks like it's been rotated this way, so rotated 90 degrees this way, and then it's been reflected over to become here. But all the angles are the same, all the sides are the same. And so we have ostensibly the same triangle, but it's just been moved in space, and and sort of the way the points have been laid out are changed, but the distances between them exactly the same. All right. Triangles have a set of conditions necessary for congruence. Okay, so in this part level of geometry, you're going to be constructing, in a way, these things called proofs, which means that you will suggest certain things that are true, and then building a case for why that is the case. All right, to be able to say these two triangles are the same because of this particular thing. Okay, so now we're going to look at the rules of how you can say whether two triangles are the same. Okay, so for example, if this was a triangle ABC and this was a triangle DEF, okay, one of the triangle rules is SSS, which means side, side, side. So if two triangles, as you can see here, have exactly the same lengths for their sides, so those are the same, those are the same, those are the same, okay, so the corresponding sides are all exactly the same, they are congruent, okay. The way that we write congruence, so we would write triangle ABC is congruent, so 3 triple equals is congruent to triangle DEF. Okay, so that's how you would write congruent. So the triple equal sign here means equivalent to, and it's this here, you might remember from previous years, this is how you write a triangle in mathematics using the points. Okay, so the first rule there is side, side, side. That's how you know you've got exactly the same triangle. All right, that one's pretty obvious. Now we'll move on to some of the more interesting ones. So this is side, angle, side. All right, so I'm going to go again with our triangle ABC, DEF. Okay, now this one's called side, angle, side. So if we look at the side BA on this one here, which is here, it is exactly the same as side EF over here. There is an angle ABC on this one, an angle FED, this one here. Okay, that's exactly the same. And the side on the other side, opposite to the angle, is also exactly the same on each triangle. Okay, so you can kind of see that all that's happened to this triangle has just been rotated a bit. All right, but because it has side, angle, side, so see, side, angle, side, means we're allowed to say that yes, these two triangles are exactly the same, because we don't need to know about this side here because it can't be any different. All right, if there's an angle and then we know the sides either side of that angle, the third side of the triangle has to be the same on both triangles. All right, some of the language I'm using might be getting a bit confusing, but hopefully it's with this sort of stuff, it's about seeing examples, having a go at stuff, and starting to see how these rules kind of fit in. Okay, right, AAS. So what this means is if you've got two triangles with two angles next to each other, like here and here, and those two same angles are next to each other as well in the second version of the triangle, and then you've got a side length, you know that it's definitely going to be the same triangle. So you can see again with this one, it's just been a slight rotation of it going around that way. And so angle, angle, side is another one that you're allowed to use. Okay, angle, angle, side. All right. Lastly, right hand side. Okay, so if you've got a right angle triangle, so you've got the right angle here and the side length of the hypotenuse, then as long as you've got one of the other two sides, you're okay to say that these are exactly the same. All right, so for this one here, you need to have that it's 90-degree triangle, the hypotenuse, okay, and the hypotenuse is the longest side of a right angle triangle, and one other side. And you're allowed to say that those two triangles are exactly the same if you've got that information about both triangles. Okay, right, probably the best way to, probably a way to sort of help see how this all kind of fits in would be to see a counter example. So if we had two triangles, so I'll try my best to draw these similar. Okay, so if we have this triangle here, no. Okay, so we've got this triangle here, and then if I draw the same kind of triangle but bigger, okay, so that triangle's just been enlarged and moved over a little bit. You'll be able to see that this angle's the same angle as this. Sorry, not two lines. So two lines, this one's the same as this one, and this one is the same as this one, okay? But those two triangles are not congruent because this one here is larger, okay? So this triangle here is a lot larger, and so these triangles are not congruent, okay? So that's why we can't use angle, angle, angle as one of our rules to say that two triangles are congruent to each other. So that's a bit of a counter example there to show you a little bit more about how this kind of works, okay? Now, sorry if this lecture, if this video is a little bit confusing with some of the language or the way some things are explained. I'm probably going to take some time in class to talk about it a bit more. But again, it's one of those ones where, as you start trying some of this out, you'll see how it works. You'll see how those different rules sort of fit in with things, and you'll become a lot more confident and a lot more comfortable with it. Okay, thank you so much for watching, and I'll see you at school.